let's do it. This workshop today we're going to talk about solving equations. We'll start with some very, one-step equations, some basic ones, and then work our way up to more involved equations, and then some of those including fractions, everybody's favorite, and some decimals as well, and show you how we can get rid of those and make those a lot easier to work with. So on the back of the first page, you should see some paragraphs and some sentences there. And I kind of made this up to like a step-by-step of what we should be doing when we're solving equations. Right? Like our goal is to isolate the variable, get the letter by itself. That's our ultimate goal. And we can follow these steps to get to that goal. Like the first one says we need to use the distributive property to remove like parentheses and things like that. So let's start the top of the second page. We have some one-step equations. X plus 5 equals to negative 12. So we don't have any parentheses or anything to get rid of here. We just have one step to do. We need to get x by itself. So what do you think we need to do there to get x by itself?
Subtract 5.
Subtract 5, right? Because we're doing the opposite of the operation. We're adding 5, so we need to subtract 5. So that's going to cancel out and leave us x, which is what we want. And then what's negative 12 minus 5? Negative 17. Sometimes the signs are confusing. Be careful. Either use a calculator to make sure you're correct, or think of it this way, if I owe somebody $12 and I borrow $5 more from them, I now owe them $17. Money always makes a lot of sense when you're dealing with the signs. Okay. So that's one step. So let's try another one. X minus 6 equal to negative 20. So if the opposite of addition was subtraction, what should the opposite of subtraction be? Addition. So we're going to add 6 to both sides, leaving us x, which is what we want. And what's negative 20 plus 6?
Negative 14.
Negative 14. Take the difference between the two numbers because they're different signs, and take the sign of the larger. Any questions on those two? So let's talk about multiplication and division. If I want to get rid of that negative 7 to get x by itself, what would I have to do?
Divide.
Divide, right? Why wouldn't I add 7?
I said the wrong thing.
No, it's fine. But why wouldn't I add?
Because it's negative 7x.
And what is that negative 7 doing to that x? It's multiplying. So we have to use the opposite operation. So we're going to divide by negative 7. Now, why wouldn't we divide by a positive 7?
It's the last step of the equation solved.
What would happen if I divided by a positive 7? What would that leave me with?
It would change the answer.
It would change it to a negative x, right?
Yeah.
We don't want a negative x, we want a positive x. So when you're dividing, always divide by the whole number, whatever that is. Negative 7, you want to divide by negative 7. Because a negative 7 divided by negative 7 is 1, a positive. So what's negative 35 divided by negative 7? 5. Negative divided by negative is positive. So that gives us x equal to 5. Now everybody's favorite. X over 4 equal to negative 9. So if the opposite of multiplication was division, we're dividing by 4 here, what would you think the opposite operation here is? What we need to do?
Multiply by the reciprocal?
Yes, we would multiply by the reciprocal. In this case, it's just 4, right? So we just multiply both sides by 4. What's going to happen with these 4s here? They cancel. Think of it as 4 over 1. The 4s would cancel, correct? leaving us with just x. And then what's negative 9 times 4? Negative 36. So that's how we deal with multiplication and division. Any questions on those? A question on that one or good? Okay. So if I wanted to get x by itself here, what do I do?
Add 13, 25.
Add 13.
Right. It doesn't matter that the number's back over here. We're still subtracting 13 because it's a negative 13. So we're going to add 13. So what's x going to end up being equal to? 38, correct. Let's try this one over here. Negative 2x over 3 equals 5. What do you think we'd have to do there in order to get x by itself? I heard it real low, but I heard somebody say multiply by the reciprocal. Does everybody agree with that?
Yeah.
Yes? Want to agree? Let's think about that. Let's multiply both sides by the reciprocal. What's going to happen on the left side?
You're going to get x by itself.
You are going to get x by itself. And why will we get x by itself?
Because they cancel two
Right. A negative times a negative is positive, right? And then the 2's would cancel and the 3's would cancel. Leaving with x. And that's our goal, right? We want x by itself. On the other side, we could put that 5 over 1. Couldn't we just multiply across? Yes, Kurt,
Yeah.
we can. All right. 5 times negative 3? Negative 15. 1 times 2. Does that reduce?
No.
Nope. That's right. So if you just have a fraction times a variable, just take the reciprocal and multiply by both sides. It's just one step. You basically just have to multiply the reciprocal times the other side, and that's your answer.
For that one, couldn't you say subtract 25 to both sides and still get 38? Or no?
Okay. So let's take a look at that. Everybody have this one? We good on this one? Yes? You guys are way too talkative. So,
I'm sorry. When we have the reciprocal, we don't change the sign, we keep the same sign.
yes, because if you don't, you're going to end up with a negative x. You don't want a negative x, you want a positive x. So someone asked if I could subtract 25, and I end up with the same answer. So what is that going to give me on the left side? Negative 38. I still have the x there. That leaves me with 0. So,
Oh no.
yeah, there's a way to get back to this, but I've created more steps for myself. I could, add the 38 over, or subtract the x, but that just creates a lot more steps.
Yeah, and you can't divide by 0.
Right.
Right.
Well, we're not going to divide by 0 in this case, because if you move the x over there, that's going to be a negative x.
Oh,
So there will
you
be
don't want
something in
that.
front of the x. It's actually easier just to leave the x where it's at and move everything else.
Okay.
Good question. So, those are some one-step equations. So let's turn that page over. And let's take a few more steps. So 3x minus 42 equals negative 12. So on the back of that first page, you know, we had those steps there. And this is where when you have more than one step, these steps come in handy. So do we have to move, are there any parentheses involved in this one? No. The second step involves if we need to get rid of fractions or decimals. Do we have any fractions or decimals in this equation? No. Do we need to combine like terms? Is there any like terms on this side or this side that we can add together? No. So the variable doesn't appear on both sides. We want to move the subtraction away. So add, say that again?
Add 42 to both
Add
sides.
42. Yeah. We want to take care of the addition and subtraction first. Once again, why don't I want to move the 12 over to this side?
Did you want to negative that?
I want to get the variable on spot, so
Yeah, we've already got our variables already on the left side, right? So we want to move everything away, get everything away from it. So 3x equals
30.
30, correct? Now I need to get rid of any multiplication or division that I have.
3x by both sides equal 10.
So we're going to divide both sides by 3. So x equals 10, correct. So notice we have to take care of our addition and subtraction first, and then work with our multiplication and division. Kind of like a reverse order of operations. Everybody good on that one? There's no parentheses or fractions or decimals. It's just kind of a little bit different than what we did last problem. We want to get y by itself. So what do I need to move first? Which one?
Subtract 18.
Subtract 18.
Okay, let's subtract the 18. What does that leave me on the left side?
Negative 5.
Right, don't forget there's a negative symbol in front of that y. We still need to bring that down. Negative 18 and negative 18?
Negative.
Right. When you're adding together two negatives, just add them together and keep the sign. Can I leave it like that? Am I done?
No.
No, I need a positive y. What does that negative in front of the y represent? Yeah, it's like having a negative 1 there. So what could I divide both sides by to get rid of that negative 1? I'm just going to divide both sides by negative. That leaves me with y. And then negative 36 divided by negative 1. Positive 36. Basically just changes the signs. Questions on that one? No? You're waiting for me to get through all those fractions. I can tell. All right. Let's go to the next one. There's no parentheses. We don't have to worry about using the distributive property. No fractions or decimals. Can I add like terms on any one of the sides? Yes, on the left side, right? What's 12 minus 30? Negative 18, okay. Does it matter that my x is on the right side?
No.
No, I can still isolate it.
You're gonna add negative, or gonna add 5 to both sides.
Exactly. I want to isolate that x, so I'm going to need to get rid of that minus 5. So plus 5.
Negative 13.
Negative 18 plus 5 is negative 13. And that means the same thing as this, right? If you just want to have that x on the left side, you can just change it right there, turn it around. It means the exact same thing. Okay. Any questions on that one before we get to fraction problem?
Oh,
Yes.
how come you couldn't have said that first, added, negative, added 30 to, the 5 first, and then continue from there?
So you're saying it added 30
Yeah,
here?
how come you couldn't have done that?
Well, let's see where that takes us. Negative 5 plus 30 is plus 25, right? Then what would your next step have been?
Yeah.
Right, but I mean, your goal would still be to get x by itself,
No.
so
You got negative 25 both sides.
Yeah.
you still get negative 13.
Oh, okay.
You would still get negative 13.
Okay.
But
I was
if you
thinking
get,
of,
if you get in the habit
solving it
of
and
moving
then
stuff
going
here and then moving stuff back, sometimes that gets confusing. So I would follow the steps that we have on that one page where add together what you can first and then see, oh, I need to move that over here. Okay?
okay.
Not wrong, just fewer steps.
Yeah.
Let's deal with these fractions. 1/3.
1/3 x minus 5/6 equals 3/4 x plus half.
Lots of times I see people, they see the fractions and they just, no, I'm not gonna do that, I'm done. Skip over it or pass out. But we can clear them out and we can take the teeth out of this problem. As long as you have an equal sign, something that separates one side from the other, you can balance it out. And we can multiply by our lowest common denominator in order to clear those fractions. So looking at my denominators, I've got 3, 6, 4, and 2. What's the lowest number that 3, 6, 4, and 2 go into?
12.
12? Did everybody do 12?
Yeah.
So what we're going to do is we're going to multiply everything by 12. And it's not 12 over 12. That would be 12 over 1. And we're going to basically multiply it times every single piece. And even if there's whole numbers in there, you would still have to multiply it by those as well. We just have all fractions here. So I have 12 over 1 times 1 over 3. What is that going to give me?
4x.
4x. You say, well, how did I get that? You can just do that work off to the side. There's two ways of doing that. 12 over 1 times 1/3, you could cross cancel. And that would just leave you with 4. Or you can multiply across, giving you 12 over 3, which still gives you 4, right? Either way's fine, either way's correct. So 12 over 1 times 1 over 3 gives me 4x minus 5 over 6
-10.
minus 10. 12 over 1 times 3/4,
Nice.
9x.
That's 6.
12 over 1 times 1/2 is 6. And that looks a whole lot better to deal with than the fractions, right? A lot easier to deal with. Do I have any like terms that I can add on this side?
No.
On this side?
No.
Nope. So now our goal is to get all of our x's on one side and all of our numbers to the other. It doesn't matter where you move them as long as you got x's on one side and numbers on the other. If you want to move your x's to the right and your numbers to the left, that's fine. Most people like moving the x to the left. So let's do that. If I were to move that 9x over here, what would I have to do?
Subtract 9.
Okay. So 4x minus 9x, negative 5x. And that's 6. So if I moved all my x's over here, what do I need to move over to the right?
Add 10.
10. So let's add 10. So that gives me negative 5x equals 16. I'll move that over here. My last step to get x by itself would be to do what? Divide by -5 to get x by itself and positive. How would I write 16 over -5? We want to keep it as an improper. You don't want to introduce mixed numbers. Just keep it improper, that's fine.
Divide
So-
it and give it a
So
decimal.
next we'll just
Yeah.
16 over.
Can I keep a negative on the bottom of a fraction?
No.
No?
No. There's a few things that you can't have in the denominator. You can't have a 0, and you can't have negative numbers or radicals. The denominator is very picky. Well, somebody a long time ago said it's picky. So you can either move the negative out in front of the whole fraction or put it in the top, but that means the same thing. Okay?
And
But never leave a negative number in the
negative
denominator.
3.2 is the same thing, right?
Yes,
Negative
but your instructor probably will say something about just leave it in the fraction. 3.2 is the same. As a general rule, if your equation starts with fractions, if your answer is a fraction, leave it as a fraction. If your equation involves decimals, then make your answer into a decimal. Okay? If need be. Any questions on that one? Right, there's a whole bunch of steps on that one. So on our steps, the first one says use the distributive property to remove grouping symbols like parentheses. So that's our first step if we have parentheses involved. Do I have parentheses involved in this one?
Yes.
Yes. So I need to distribute 10 times 2x and 10 times -1. So 10 times 2x would be 20x. 10 times -1, and 10. 3 times 7x, 12. Yeah, and why am I not multiplying that 3 times the -16? It's not parentheses, it's just left out before a little -16. So, can we add any like terms on the left side? Nope. Can we add any like terms on the right side?
Yes.
Yes, so let's take care of that. I'm going to write everything else down that we're not putting together. 12 minus 16. -4. Now we're back to what we did last equation. We need to move all of our x's to one side and all of our numbers to the other. Does it matter what side we move the x to?
No.
No. So if it doesn't matter, I'm going to move this x, I'm going to subtract 20x and move it over here. Because I'm noticing that's going to leave me with how many x's? 1x. That's what I want. I want a positive. I just want 1x. So I've got -10 equal to 21x minus 1x is just minus 20x is 1x. So if I want to get x by itself now, what would I need to do?
Add 4
Add 4.
to both sides.
I move my x's to the right, so I need to move my numbers to the left. Yep, so x equals -6. -10 plus 4 is -6. Everybody good on that one? Yes? parentheses I need to get rid of on that one?
No.
Nope. Any fractions that I could get rid of?
Yes.
Yes. So if I'm looking at this equation, what would my lowest common denominator be?
4.
4. I have 2 and 4. My lowest common denominator would be 4. So 4 over 1. And I'm going to have to multiply that times every single piece. Whole number and fraction. So 4 times 4 is 16. Easy enough. 4 over 1 times y over 2? 2y. Correct. The 2 goes into 4 2 times. 2 times y, 2y. Equals, on the other side, 3y, right? The 4's would cancel. And then 4 times negative 1. Negative 4. Fraction's gone. A lot easier now. Now, once again, just like last problem, is there any way we can move my y's to make it a little bit easier? To the right, right? You know, don't just give me 1 y. It's not wrong to bring it over here to 3y. Just it might create a little bit more steps. And if I wanted to get y by itself, add 4. So 20 equals y, which means the same thing. If you want to see that y on the left side, y equals 20. Any questions? Fractions. Piece of cake. Not so bad. So let's move to the last page. See what that entails. Can I erase this one? Everybody good on that one? Now, I know some instructors show how to get rid of the fractions before getting rid of the parentheses, and sometimes that's really confusing. So I always try to get rid of the parentheses first, because it makes it a lot easier. Does your instructor get rid of the parentheses first and then clear the fractions? Yes? All right, we got one nod in the head. So I'm going to clear the parentheses first. 2/3 times x, and 2/3 times negative 3. So what's 2/3 times x? Just 2/3 x. 2/3 times negative 3? Negative 6/3. Let's do that off to the side, so we might be able to write it as something a little bit easier. So someone multiplied across and got negative 6 over 3. Can we reduce that? What's negative 6 divided by 3?
Negative 3.
Oh, negative.
Oh, 2, so right.
So we're just dividing there. 3 can't go into negative 6 evenly, so we'll write that as negative 2. It's not wrong to leave it as negative 6/3 because we're not to the bottom. We don't have to reduce it yet, but it'll make it easier as we're going along. 5/6 times x. 5/6. And then what's 5/6 times 1? 5/6. I have an equation with fractions in. Can I clear them out? Yes. And what number would I use to clear them out? 6. 6 is my LCD. So 6 over 1 times 2/3. 4. And 12 over 3 will be 4x. 6 times negative 2. Negative 12. 6 times 1/6. 1. 6 times 5/6. 5x, right? The 6's would cancel. Then 5x. And then 6 over 1 times 5 6 again,
5 plus 5.
plus 5. So we clear our fractions out. Next we want to look, are there any like terms I can add together?
Yes. 12 plus 1. Negative 12 plus 1.
So negative 12 plus 1 is negative 11. 5x plus 5. So now we need to move our x's to one side and our numbers to the other. Any suggestions there?
4x subtract.
Yeah. It's not wrong to move the 5x, but if you see that we move the negative 4x over there, that's going to give us a positive 1x, which is what we want. So that's going to be x plus 5 on this side, and negative 11. My last step there to get x by itself,
Subtract 5
subtract 5.
on both sides.
So that's going to leave me with negative 16, right? A negative 11 and a negative 5 equal to just the x. So x equals negative 16. So that kind of went through everything, right? We had parentheses involved, clear fractions, add like terms, add and subtract, to get to our final answer there. Any questions? If you follow those steps on every equation, you'll always get the right answer. As long as your arithmetic is great. This one we have parentheses. What do we have to multiply through that parentheses? Negative 1. If you have a negative sign for parentheses, that's like assuming we have a negative 1 there. So we're going to take a negative 1 times both pieces. So I still got that y. And then negative 1 times 3.3. Just changes the sign line. Negative 1 times 0.5. Yep, it's the same thing, we're just changing the sign. Equals 6.7. So, yes.
So, when there's like a y and then you said the negative sign and then not, there isn't a number, you just assume there's a 1 there?
Yes, just like we know there's a 1 in front of this y right here.
Okay.
Right, that negative sign just means there's like a negative 1 there.
Because there's parentheses.
Yes. Yep. So, just like fractions, we can clear decimals. You don't want to work with them. What are all my decimal places? Like what decimal place is this right here?
Tenths.
10.
The tenths, tenths. So the largest decimal place, the most number of decimal places I have is is the tenth. So I could multiply everything by 10. And that's going to clear my decimals. But we have to multiply by everything, even stuff that doesn't have a decimal. So 10 times y, 10y, 10 times 3.3. It just moves the decimal one place over. 10 times 0.5, we'll just make that 5. And then 10 times 6.7, 67. So we've cleared our decimals out. Any like terms we can add on the left side?
10y.
10y minus 5y. What's that?
5y.
5y. What do I need to move now? 33. What's that? 33. 5y left on the left side. 67 plus 33? 100. We'll move over here. 5y equal to 100. My last step in order to get y by itself would be to do what?
Divide by 5.
Divide by 5. And what's 100 divided by 5? 20. If I would have kept my decimals in there and worked the problem out with the decimals, would I have gotten the same answer? Yes, you would have. But if you don't like working with the decimals, you can clear them out. It's up to you. It's your choice. You'll still end up with the same answer, as long as your arithmetic is correct. Any questions on that? No? Talking group. Can I go ahead and erase this one? No parentheses, no fractions, no decimals. Any like terms I can add together on each side?
Yes.
Right. We can do that. 5x minus 13x, negative 8x. What can I do now?
Divide -48 by 8.
I got all my x's on this side and all my numbers on the other, so even though the x is over here, it's okay. We can still isolate it. Negative 48 divided by negative 8. Positive 6, right? Negative divided by negative is positive. So I get x equal to 6. Kind of anticlimactic after the last couple. There's only a couple steps. More here. 11 minus 6y equal to y plus 21. So someone talk me through that one. Let's see if we can all agree. What would my first step be?
Subtract 11 from 21.
Okay, someone said we can subtract 11 from 21. So what does that leave me here?
0. Or minus 6y.
Okay, that part's still there. All right. I hear that. That is 0. That's correct. And then what does that leave me with on the right side?
Y plus 10.
There we go. Okay. What do we actually do now?
Subtract
Subtract
y
y
from
from both sides.
Correct? Negative 7y, right? Negative 6 and negative 1 is negative 7y. 10. We'll move it over here. Negative 7y equal to 10. What do I do now? There you go. Right? We don't want to leave that negative in the bottom. So negative 10/7 would be the correct way to write that. Would it have been wrong to move the y first and then move the 11?
No.
No, it doesn't matter. As long as you end up with y's on one side and numbers on the other, it does not matter which one you do first. Any questions on that one? All right. Fix that one. Last one. Thank you. Parentheses, okay, so how did I do that?
5 times 2, 5 times
So, tell me what I'm gonna write on this one.
9A negative 10
Negative 10.
plus 5A. Or
Negative.
Alright, I'll go with negative 5. What would my next step be?
Combine like terms.
Combine like terms. So what can I combine and what am I going to end up with?
9A, combine 9A,
Okay, so how many A's do I have? Okay, minus 10, 26, okay?
add 10 to both sides.
Add 10 to both sides. So we got 4A equal to 26 plus 10, 36. Last step,
Divide by
Multiply 4,
4.
A equals 9.
Yep. So A ends up being equal to 1. So that kind of gives you some steps, you know, no matter what they throw at you, if you follow these steps on each equation, you'll be good to go. Okay. Any other questions? Comments, concerns?
Are you gonna do a workshop on the word problem?
The workshop on word problems for 0310 will be later in the semester when you guys get into the 2 variable word problems. Right now, because right now you only have 1 variable, and it's not so bad. The 2 variable ones are usually the ones that are a little bit trickier. So there will be one for 0320 in a couple weeks that might help, but that workshop will be the same one you will see later in the semester because that's when 0310 will be. Okay?
Yeah.
Fine. Anything else? You good to go? Ready for your test on Tuesday? If you've got a whole bunch of tutors across the hall, come by and see us.
I can feel the word problems.
But remember, your test is not going to be all word problems.
No,
So
still.
they're going to be there, but you know, focus on this and then
This
the
is
word.
okay now.